In section 3.2, we're going to talk about conditional probability and the multiplication principle. To motivate this concepts in this material, let's look at the following situation. Let's suppose that we have a bag that has 7 marbles in it. And let's suppose that 3 of them are red and 4 of them are green. What we're going to do is we're going to draw 2 marbles, and the selection is going to be done without replacement. Okay? Throughout the remainder of this chapter, one of the common themes that we'll see is whether or not selection is being done with or without replacement. When selection is done with replacement, then whenever an item is chosen, it is placed back in the selection pool, and it's possible for it to be selected again. However, when selection is done without replacement, then once an item has been selected, it is then removed from the selection pool and is not allowed to be selected a second time. Let's define event A to be that of drawing a red marble on the first selection, and we're going to let event B be that of drawing a green marble on the second selection. What we want to ask is the following question. Given that event A has occurred, what is the probability of B? Meaning, what is the probability of B given A? And we call this a conditional probability. This is the conditional probability that event B will occur given that A has already taken place. And when you look at this notation, what we see here is that it's P of B with a vertical line. This is read given A. This means the conditional probability of B given A. Well, let's see what the circumstances are for this particular instance. If we know for a fact that event A has already occurred, then that means that we actually selected a red marble on the first pick. And because the selection is done without replacement, that means that we're now down to 1 fewer marble, so we now have 6 marbles left in the bag. Furthermore, that 1 red was taken out, so now we're down to 2 red, and we would still at that point in time have all 4 green marbles left in the bag. So when we go in to take our second selection, this is the circumstances we're working on. And at that point in time, there's 4 green marbles out of the total of 6 marbles, which is the probability of 4 over 6, which would be 2/3. So the probability that B given A is equal to 2/3. If you wanted to put that as a decimal, that would be 0.667. Okay. So this is what we refer to as conditional probability. It's the probability that an event B will occur given that, or on the condition that some other event A has already occurred. And again, the notation for this is P of B given A, where we have a vertical bar in between. We're looking for the probability of B given that A has already occurred. Let's take a look at example 1. Suppose we have 2 cars that are selected without replacement from a warehouse of 50 cars. We know that 5 of the cars that are in the warehouse are defective. What is the probability that the second car is defective given that the first car was defective? So one of the things that's going to be especially important in this entire chapter is picking up on the key buzzwords. All of the questions are going to be more or less of the form compute the probability, but when you hear that buzzword given, that's what makes it a conditional probability. So let's let event A be that the first car selected was defective, and let's let event B be that the second car was defective. In the very beginning, we're told that we have 50 cars in the car lot. 5 are defective, which means that the remaining 50 minus 5 or 45 must have been good cars. If we know that event A has already occurred, so the remaining 45 cars would be good. If we know that we already selected a defective car on the first pick, then that means we're now down to 49 cars because the selection is done without replacement, and we've already removed one of the defective cars, which means that there's still 4 defective left out of 40 and 45 good cars remaining as well. The probability that the second car we select is defective would be selecting one of those 4 out of remaining 49 cars, which is a probability of 4 out of 49. Let's take a look at another example. Suppose we're going to select 2 cards from a deck of cards, and the selection is going to be done without replacement from the standard deck. What is the probability that the second card is a queen, given that the first card was a king? So we want the probability of a queen given that we selected a king. And again, it's done without replacement. So we already know we're given that A occurred. So we reached into our deck of 52 cards, we selected one of the kings, and we've now removed it from the deck. When we go to make our second selection, there's now 51 cards remaining. And because we didn't select a queen yet, that means that all 4 queens would still be left in the deck. So the probability of selecting a queen, given that we selected a king, would be 4 out of 51. The next thing we're going to discuss is that of independent events. Intuitively, 2 events A and B are independent if the occurrence of one event does not affect the probability of the occurrence of the second event. Okay? Notationally, we can represent that as follows. 2 events A and B are independent if the probability of B given A is equal to P of B and the probability of A given B is equal to P of A. Okay? So again, if A has no effect or no bearing on the probability of B, then just knowing or given that A occurs should not impact P of B, and therefore the conditional probability of P of B given A is simply going to be equal to the probability of B in general. Okay, and the same thing works in reverse. Okay. If the 2 events do affect each other's occurrence, then they are not independent and they are labeled dependent events.